Alright, so today we're going to talk about mean, median, and mode. You all remember mean, median, and mode, right? Okay, turn to your neighbors and tell them what mean was. What is a mean? How do you figure it out? Okay, what's the mean, everyone? Let's add a bunch of numbers. What's a mean?
That's the average number.
It's the average, that's right. Mean is the average. How do you get an average? That's right, good. That was perfect. Okay? Median, what's a median? Talk to your neighbors. What's a median? Middle number, right? So middle number. So what if I had a bunch of numbers that were all disorganized? So I just take the middle one that I pick?
No, you have to put it in order.
You have to put them in order from least to greatest good, and then you pick the middle. What if you have two middle numbers?
They're both.
They're both.
Good. Good. Brandon got it, and then Braden. That's right. You add them together and divide by 2. That's right. Now, what's the mode?
Often.
The number that comes up the most often. Does that make sense? Okay, good. So, mean, median, and mode. Excellent. Okay? So, we're not going to focus on that so much. We're going to talk about box and whisker plots. And the big idea is when we want to think about 100%. Okay? So, let's say there are 35 kids enrolled in my class and all 35 are here. How many percent of kids are here? Good. So, how many kids represent 100% of kids? 35. Good. Okay? So, let's make this a little bit more simple. Let's just say there were 16 kids in here, okay, and all 16 are here. How many percent is 100%? Or I'm sorry, how many kids are 100%? 16. Good. So how many kids are 50%? 8. Good. How many kids are 25%? 4. Good. Okay, does that make sense? That's all we have to go down to is 25% for box and whisker plots. Okay. So let me pull up the lesson I've done before. Okay, so we're only going to focus on these steps right here. If you're on the video, please pause and write down these highlighted steps. Alright, so we're going to keep going here. So, here we go. So, I'm actually going to focus on number 1 here only for this period because we have a shorter period. So let's just say I was collecting data. Let's say I was wanting to know shoe sizes. Okay, and I wanted to understand what it looks like in this class, and I asked all the students that are in here what their shoe sizes are. Okay, in a class. Let's pretend that this is all the data I can get. I went to everyone. I said, "What's your shoe size? Shoe size? Shoe size? Shoe size? Shoe size? Shoe size?" And this is all the data. Okay.
I have a size 20.
Okay. So, how many total people did I ask?
1, 4, 5, 6, 7, 8, 9, 15.
Good. 15. Do you all agree with Tommy? Good. Good job, Tommy. All right. So, 15, right? That's called our sample size or our N. N is equal to 15 here, okay? So, like, approximately how many people is half or 50% of 15?
7.5.
7.5, 8 people, right? Approximately how many people are 25% of 15?
4.
Almost 4, right? Are y'all following me so far? Yes. Okay, good. Just want to make sure we got that concept. All right? So, the first thing I want to do is organize these numbers. I'm going to make a box and whisker plot. I'm not really going to worry about mean, median, and mode. That was just a review. Okay? But we will talk about the box and whisker plot. So, the first thing I want to do is put them in order. So, I want you to write this in your notes as I write. Not what's up here so far, but you're going to start writing what I'm writing. Okay? So, let's start putting these in order. Can you all put these in order from least to greatest? I'll give you 20 seconds. Go. Okay, so I'm going from least to greatest, and I'll start catching up with y'all.
Whoa.
Okay, so I put them from least to greatest, okay? And your list should match mine, okay? And then I want to make sure, remember how I sampled 15 people? Are there 15 numbers that I copied down here?
Yeah.
Cool, least to greatest. Okay, the first thing I want to do is figure out what are my minimum and maximum. My minimum here is 6, the smallest size. The largest number is 12. And all the numbers fall in between. Sometimes there's repeats. That doesn't matter, but this seems to be normal, okay? 6 to 12, that seems to be normal in my data, okay? Do I see something abnormal like 20 in there or anything? Or like 15? 15 would be abnormal. What about like 2? Do I see a 2? No. Okay, so I don't see any abnormal data. So I notice this is my minimum and maximum. So what I need to do is create a nice, neat number line. It has to be straight, and it has to include numbers like really neatly. So I'd have to use a ruler if I didn't have like graph paper. But in this case, you see I'm using the dashes on my graph paper to neatly write the numbers from 6 to 12, because that's our range. Y'all see that? You see how these spaces are perfectly spaced? Good? Okay, so now this is going to be like a frame of reference. This is like our ruler. And now I'm going to start plotting 6 and 12. I'm going to put a point above 6 and a point above 12 to represent my data, and I'm going to draw a line, okay? If I ask 15 people, how many percent of people is 15 people?
100.
Good. So this line represents 100% of the people I asked, okay? How many percent does this line represent? Good. What happens if I cut this in half? How many percent of people does that?
50.
Good. Good job. So now to figure out where we cut it in half, we have to find the median. What's the median between 6 and 12? Turn to your neighbors and tell them which is the median in all of these numbers. Okay, what's the median?
9.
9. Okay, good. So, but there's 2 9s. Which one 9 is it?
Neither. The first one. Bring them down.
Neither. The first one. Any other answers?
Oh, neither.
Both? Okay, let me show you how to do this. You know how there's 15 numbers? What's 15 divided by 2? Good. So the middle number is technically 7.5, but there is no 7.5th number, so it's really the 8th number. So I'm going to count 6, 7, or starting at 6, we got 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8. 8. 1, 2, 3, 4, 5, 6, 7, 8. This 9 right here is the middle number. And we can go the opposite way. We got 1, 2, 3, 4, 5, 6, 7, 8. You see that's the same number in the middle? So this first 9 is exactly in the middle. This is called our median, okay? And we're going to use that median to draw a line here. So if you haven't drawn this on your papers, make sure you're catching up, okay? Make it look nice and neat. I'm going to give you a moment to catch up here. Did you notice that we cut this in half? So how many percent of the people are on the left side? 50%, right? How many percent are on the right side of this line? Good. And then how many people did we sample in total? 15. So what is about 50? What is about 50% of 15? About 7.5 or 8, which means I really have 7 people on the left side and 7 people on the right, or about 7.5 on each side. Does that make sense? Okay, cool. Now we're going to divide these halves and halves. What's half of 50%? Good. So now we're going to find what's the middle number between 6 and 9 here. Turn your neighbor, tell them what's the median if these were the 2 numbers. 7, right? Okay. So which one's the middle number? Which 7 is it? First one?
No.
Second one, or both of these? The first and 2. Okay, so how many total numbers do we have? We have 6. So start with 6. 1, 2, 3, 4, 5, 6, 7, 8. What's 8 divided by 2? 4, good. So we have 2 4s, right? We got 1, 2, 3, 4. This first 7 is the 4, and we got 1, 2, 3, 4. Oh, look at that. We have 2 numbers in the middle here. 7 and 7. So what would we do?
You add them together and divide by 2.
Good. So, but they're the same numbers. 7 plus 7 divided by 2 is still 7, right? So our median here is going to be 7. So let's draw a line here to represent us dividing our data, our people, in half. Okay, so this, make sure you put that on your papers. Okay? So again, I just divided 50% into 2. Okay? What's 50% divided by 2? 25. Good. So how many people are a quarter or 25% of the people of 15? If 15 people is total, what's a quarter of 15 again? You said it earlier? 4, approximately 4. So there's approximately 4 people right here, right? And there's approximately 4 people right here. Did y'all see that? And how many people are here on the very right of all this? almost 8, right? Does that make sense, everyone? Okay, good. Let's keep going. Now let's divide this part into 2. What's the number exactly in between 9 and 12? Your turn your neighbors and tell them what's exactly in the middle and how'd you figure that out. Okay, what number is exactly in the middle?
11 and 12.
Okay, good. It's 11 and 12, right? There's actually 2 numbers in the middle, right? There's no perfect number exactly in the middle. So what number will we put for the median here between 11 and 12? So let's do what Brandon says. What's 11 plus 12? 23 divided by 2? Good, 11.5. So our median here again is going to be 11.5. We're going to plot a point or a line right here, okay? 11.5, which it doesn't look like we're cutting it perfectly in half. Do you notice how I'm not perfectly cutting everything in half? Right? So what this means is we've just divided all of our 15 people into perfect quarters. There's a quarter of the people here. There's a quarter of the people here. There's a quarter of the people here, which is about, a quarter of people is 3.5, and there's a quarter of people here. Does that make sense so far? Okay, good. And we need to understand that concept as we think about it, because if I looked at the graph, it says a quarter of the people have a shoe size that is either 11 and a half or 12. Do you all see that? How many people up here have an 11 and a half or 12? How many people? 4, right? Can we tell that from this graph? You see that? There's a quarter of the people that have a 6 to 7 size shoes, right? How many people have a 6 to a 7? 4. We got 1, 2, 3, 4. Almost 4 have a 6, right? Does that make sense? Yep. Okay, cool. So now we're going to draw a box just across right here, okay? And remember that the middle is the 50%. So these 2 boxes add up to 50%. The number at the end is each section is 25%. Of course, I've talked about that. And then this first number here is our Q1. This is called our Q1. This is our first quarter. This middle line is called our median. And then this last one is called our Q3, okay? And this whole box is called our interquartile range, which represents 50% of the people. Okay? So, any questions on this so far? Raise your hand if you kind of remember this from before. Okay? Good. Okay, so let me switch this up a little bit. Let's just say that there's a student that I didn't tell you about that I forgot to add to my data. Let's pretend at the beginning I asked all these 15 students, and then I got to the last student, and I asked her, hey, what's your shoe size? And she said, my shoe size is size 20. She's a very sweet. She's a very sweet young lady, pretty, everyone likes her, very kind, smart, really good at sports, especially soccer. And swim. She's really good at swimming for some reason.
Why she got big feet though?
It doesn't matter. She's human, has a heart. We all love her, okay? But I don't know. Her name is
No, she be like
Fanny.
She has a job in mind.
Okay, listen up though. Hey, back up here. I noticed you all laughed. Why was this funny? Okay, now I know that exactly. Did you notice that her feet are not normal, right? She kind of has special size feet. Even though she's a normal human, she just does not have normal size feet, okay? You look down at her feet and you're kind of like, whoa, you got huge feet, girl, right? Okay. So her feet are abnormal, right? Does her size 20 fit within the other 15 students that we measured?
No.
No, so we call that an outlier, like Tommy said. So she wouldn't be included, okay? If we included her, it would mess up all of our data, okay? Because she would make it look really weird, so we don't want to include her. So we don't want to include her feet. Feet, okay? All right, so, but we're going to include her.
It's discrimination.
Don't be rude. Okay, so we still want to include her. She's still part of our sample, okay, even though she has an abnormal sized foot, okay? So what we would do is extend my my line here that measures all the numbers. We'd still use our ruler, and we're going to extend it out to 20 as well as we can, okay? And on my graph paper, I'm actually going to run out of space here, but you know, you get the idea. It's going to go all the way out to 20, and then I'm going to put a point out way out there for 20, which is all the way out here, okay? And this was called our outlier, okay? This was called our outlier. What's this called?
Outlier.
Okay, cool. Meaning it's an abnormal number. It's an outlier. We still include it, but it's not going to be part of the normal group of people. Does that make sense? Okay, so she has abnormal feet. It's not that she's abnormal, she just has abnormally sized feet. Okay? Or it could have gone the opposite way. What if I said her shoe size was a 2? Is that normal in this group? What if it wasn't 20 but rather 2? Would that be normal? No, it wouldn't, because all the group of people is from 6 to 12. Okay, does that make sense, everyone? Okay, cool. So that ends the lesson on box and whisker plots.